All right.
This is a Loom Logger presentation.
All right. So the logger is the newest version of how we actually like convey messages and important debugging information to the user. Before, like I mentioned last time in the or just like 2 weeks ago, in the manager or in the module rather, we used to use this print module function here, which basically just appended whatever message you had to like the module name so you could see what was actually logging. But since then, we've added a whole static logger class that you can basically include in any of your CVP files. Because it's a static class, you need to include it in your CVP file instead of your header. So that's not a great example because that one hasn't updated yet, but as you can see, it's at the top here instead of in the header. That's just how it needs to be for it to work properly. The main way you interact with the logger is via these macros here. You shouldn't need to actually use any of the functions inside of it, although you can. It's really not recommended. Effectively, what these do is they just, when the code is compiled, this is just a generic like definition of what a macro is. When the code is compiled with one of these, it effectively takes this version, which is present in your code, and converts it into this line here. And basically, it just makes it easier to read the code that you're writing. Because you don't have to have long copy and paste lines. Effectively, there's you probably use 3 of these fairly often. There's a couple other ones here that are less often used for logging stuff. These, which I'll come back to them in a second. These 2 here are the ways you actually enable different functionality of the logger, which one of the main benefits of using the logger over just serial prints is that anything you like request to log on will be logged to the SD card as well in an output file, assuming that enable SD logging is enabled. Or this macro is called at the start of your INO file. So like, for example, if I go open up weather chimes and then the tipping bucket example here, and then there, you'll see that the top here, I've enabled both the logging and the function summaries. And again, you'll see that the logger is included up here as well. And so if we, so coming back to the logger, these are mostly used for under the hood code, as in module functionality and stuff. These allow the logger to track how much memory and the like response time of different functions, and create a summary of them in a nice output that has all the different information you need. Effectively, it's just there so that you can fairly easily debug memory leaks, where you can have code that is not freed and then it just continues taking up more and more memory until your device eventually runs out of memory and crashes, which is a problem we were having in weather chimes because we were using too many strings in the Arduino string sense because they're bad and you shouldn't use them. They like fragment memory too much, and then it'll eventually lead to you running out of RAM.
We had another great case study that we're going to tune into.
You should talk into your computer.
So we also had another really great case study talking with the Loom team here about remember the lily pad? So lily pad, they had to integrate in the solar radiation sensor that we've never used before, but it was requested by the client. They used the library just straight up, thought it was fine, and things kept crashing all of a sudden. And we were sort of spinning our wheels for a while because we never blame a third-party library for like I mean, they're supposed, we assume that their code is good. However, upon logging the memory leak issues, it was discovered that they were misusing a variable, not clearing the memory of the. Do you remember exactly what the variable issue was?
I think it was like a begin call that was like inside it had like a bunch of new statements, so it was creating a bunch of dynamic memory, or it was allocating a bunch of dynamic memory, and because you called begin every time the device woke back up, it was just creating more and more memory used on the heap, and so it was just crashing eventually.
Yeah, so if that this memory logging thing is really handy, like if you're getting things that are just crashing all the time, that's a really good debugging tool to figure out like, am I crashing because of a memory leak? Because the code looks fine, right? All right, keep going.
Yeah. And then those can be enabled through this macro here. Coming back to the actual logging statements themselves, we'll just work our way down. The slog is a slight variation of log. All it does is it just, hold on. It logs a message without printing it to the serial. So it's like a silent log, and just the S. Log just logs a generic debug message. There's 3 different trace levels, or I guess log levels. In Loom, there's debug, error, and warning. Not super in depth, but we don't really need anything else.
Why have these 3 different layers?
Because it makes it, if you're, let me see if I actually have the file. Because if you have, oh, this is like, never mind. This has like no issues in it. But you can open it in VS Code or whatever and tell it to treat it as a log file, and then it'll actually like syntax highlight the different levels. This is an old log file. Now, if you're using the Hypnos, it'll have the timestamp printed before this too, so that you can see when the messages were actually logged. I added that because there's an issue where the device was crashing and I couldn't figure out why. And it was because the device wasn't really crashing. What was happening is that the power down was taking too long. And so the interrupt that had been scheduled for however far in the future was actually triggering while the device was still awake. And so it wasn't like going back to sleep. So now you can see that fairly easily if something like that's happening with the actual timestamps there. That's also been fixed though. So if it does trigger before the device goes back to sleep, it'll just rerun the log cycle. With that said, it will also increase the packet number, so it counts it as a different packet, but that's besides the point of this. Generic log message. The log long, instead of taking in, because log and error or debug log and error log and warning log take in constant char pointers, which means that they do have a fixed length, whereas the log long just takes in a generic char pointer, which can point to an array of whatever length, really. Doesn't matter. So this is used for logging like when you call display data. That's how it prints out the actual packet, because those are fairly long. Error and warning are just same thing as log, pretty much. Just it's just error or warning instead.
Are you using those macros in the display data function for this?
For the log long stuff?
Or maybe log SD. Like, is this all part of the log SD situation?
What do you mean? Like for
are these macros in use in like kind of the lower level modules?
Oh yeah.
You want to show us like
yeah. So here, if I just go, let me look at the manager actually. We should be seeing the manager. So let's see here. Log. So yeah, that said, the log and all the different log levels also support these F strings, which are basically what that. This is another macro, but all it does is it, instead of writing the string to RAM, it will store it in the program memory in the flash, which there's significantly more of. So if you have really long strings that are always going to be there, then you can treat them as this, and they just won't use up as much RAM.
That is the best practice when you're in an Arduino.
It is, but honestly, with the Feather M0, it doesn't matter a whole lot because there's a crap ton of RAM comparatively to most microcontrollers. But other microcontrollers, that is definitely a best practice. So not all of them in Loom are using this F macro, but a lot of them are. Yeah, so for example, here, this is the display data thing that I was talking about, where you call normal log to print out the data, like the initial like header part, and then you call log and pass the string in the sharp pointer into it.
Your science team so far? What do you think? All right.
Yeah. Yeah.
Great. All right. Keep going.
Yeah. That's mostly it, to be perfectly honest. There's not a whole lot else to it, considering you don't really interact with any of these lower level methods. But yeah.
Do you want to provide like any additional case studies or like using any of these particular macros? Like, would you use these on the top, very top level on your other side?
Oh yeah, no, for sure. I would recommend using it. These should be used in place of serial.print or whatever in almost all cases, because it's more verbose and informative, as well as it's just easier to debug devices if they crash in the field if you have it enabled, because it'll log everything to the SD card so you can see where it crashed. Whereas if you're just using serial prints, you won't know what happened. So, yep. Yeah. So here, I'll show you. Yeah. Basically, whenever you return from a function or end a function, you want to call them. So over this should be up here to be perfectly honest, but yeah. Effectively, this here I can actually show you. When you call function start, it's going to get, and then you compile the code, it's going to get replaced with this line here. Effectively, what this is doing is it's passing in. These are also macros that are just in C++ that correspond to, this is the file name. So I hover over it, it won't tell me highlighted. This will tell you the file name, the function that this is being called from, and then the line number that this is being called on. And then finally, you pass a call to free memory into it, which is just another, it's from the memory free library here. And effectively, it just calculates how much free RAM there is available. And then when you end the function, it'll also pass that version in there. So basically, it allows you to have a start, how much memory is used at the start of the function, how much memory is used at the end of the function, and from there, it can then compile an output, which I don't have any here to show you. But there's examples in the wiki that you can look at too. Yeah. Do you use function start? And I use it in all of them. So I like all of these here. I guess I didn't update this one. I need to go through and actually like fix some of these so that it uses them.
Can we assign that to somebody?
Yeah,
like, is that
sure. Go for it.
Yeah. Who would like to go into all of the modules and just make sure something starts? And I mean, maybe we should explain sort of why like, why are we doing that? So, well, do you want to like,
What do you mean? I just did.
oh, wait, you used it?
I mean, no, I mean, like, I explained why.
Oh, right. So back
like
in the
there.
day, let me see if like I can follow the historical thread for like why, or like why this exists. I'm just gonna go closer to the mic.
Yeah.
So it used to be that like when things would crash, we wouldn't know exactly where in the code or what function was the problematic function that was like crashing the system. In old school Loom 3, we were like we had all of these like mark things,
Okay.
like basically every time we passed a mark, it would like log like what line and sort of where it was, which was like very handy, but also like super rigorous and primitive. You had to like actually, there was a script I think we had to use to like insert a mark like every other line or something. It's like really dumb. So
It was for the it was largely for the watchdog timers so that it couldn't it would also do that so that it was reset. But it was gross. I mean it still looked disgusting.
right. So this one is a way to, I guess, log to the SD card and print for the serial if it's open, right?
It won't print the function summaries don't get printed to the serial because that would just be cluttered and actually not helpful.
Okay, so it's just to the SD.
Yeah.
All right. What was the last function? So if your device crashes, you because these are here, you ought to see what the last function was, what the memory was about. Was that right?
Yeah.
Okay.
If it crashes, it won't. If it crashes in the middle of a function, it won't actually log what the end result was.
But it'll
Because
get you.
because it won't. Yeah, it'll get you pretty close.
It'll get you close.
Because then you also have the output, which will tell you exactly what was happening when it crashed, as just from these. But yeah,
Does that make sense?
basically, when you're developing a new module, they should be put at the start and end of function, and anywhere where you return from the function early, there should also be one there. If you don't have it, then you're just going to break everything, and it will probably freeze actually, just because you forgot you have like hanging threads basically, and that's not good.
Yes.
That's pretty much it though.
All right. Other questions? All right. And so you need now manager.h and logger.h up at the top in logging stuff.
Yeah, actually, technically, yeah, yeah. Oh yeah. This is just present in manager because manager is always going to be included. It effectively just sets the instance of the logger to null pointer and then actually creates the logger, because that's static classes in C++ need you to do this because that's just without getting too into the details, that's just how it works.
Right. Okay. All right, cool. Thanks, Will.
Yep.
Appreciate that. Good.